Are you struggling with the different programming languages that you need to know in the DP-700 exam? Maybe you just know one of those languages and would like to know how to do similar things with those other two. This video is here to help you with that. Stay tuned. Welcome to the video. My name is Aleksi and on this channel I cover Microsoft Fabric and Azure related topics. In this video we will continue our DP-700 exam prep series and the link to the entire playlist can be found in the description. This is the episode 4 in this DP-700 exam prep series, and in this episode we will cover the programming languages that are in the scope of DP-700 exam. This episode should be way easier to follow if you already know how to use SQL, KQL or PySpark, since we are going to compare their syntaxes between those languages in order to understand quickly how those languages work and what are the major differences in their syntax. If you already think you know the basics of these three languages, you can skip this episode, since this is meant for people who are lacking with at least one of these, so that later episodes are not so confusing when we use these languages. And obviously I'm not going to be able to teach you how to program in this short video if you know nothing about these languages to begin with. So don't expect that kind of magic from this episode. Like in every episode in this series, we will start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now let's get started. In the scope of DP-700 exam, we have three programming languages that are SQL, KQL and PySpark. For this exam, you need to know at least the basics of these three programming languages. Let's first cover what are these languages and what are their main uses in Microsoft Fabric. We will start with SQL, since I assume that most data engineers or people looking to become one are most likely familiar with it. Also, in my opinion, this is the most important language to learn for data engineers. So, SQL. It stands for Structured Query Language, and it is mainly used with structured data, and this has been the traditional language used in relational databases for ages. Since this language has been around for so long and being used in multiple different databases and environments, many different dialects of this language have evolved, which basically means that there are just minor differences in the SQL syntax and functions, etc. that can be used with those different dialects. In the scope of DP-700 exam, we have two of those dialects, and those are Spark SQL and T-SQL. Spark SQL is one of the languages used to interact with Spark engine, and in the Fabric context, this means that this language is mainly used in notebooks, and the go-to data store with notebooks, Lakehouse. T-SQL, on the other hand, is the Microsoft dialect of SQL, and in Fabric it is used with warehouse, T-SQL notebooks, T-SQL endpoints, and also it can be used with eventhouses/KQL database to some extent as a replacement to KQL if you prefer SQL. And speaking of KQL, it is the next language that we are going to talk about. KQL stands for Custo Query Language, and unlike the two other languages here, it is a read-only request language that is meant for fetching, filtering, analyzing and visualizing data. This language excels at handling large volumes of structured, semi-structured and also to some extent unstructured data. KQL is mainly used with eventhouses and its different features in the Fabric context. I would say that if you are starting completely from scratch, this is the easiest language to learn, but I would still say that learning SQL is more worthwhile. Then we have PySpark, that is basically the Python API for Apache Spark. So when you write PySpark, you are writing Python, but since Python is a very versatile and huge language, we are just scoping it to this specific set of functions and functionalities that PySpark covers. Since PySpark is Python, this is the most versatile language out of these three, and you can really do many things with this language that you can't really do with KQL and SQL. However, the downside is that this language is the most difficult to learn for a beginner, in my opinion, and I think most of you can agree when we compare these languages side by side shortly. Since this language is used to interact with Spark engine and it is used in similar fashion to Spark SQL, which means that it is used in notebooks and interacting with Lakehouse. Next, let's compare these languages side by side to highlight the differences in their syntax. And here we have our input table / data frame that we are going to read or query using these three languages. Let's begin with SQL. With SQL syntax, we would write select name and age from person, which would then result as having all the rows that we have in our input, but by just having only the specified columns that are name and age. So, for those who are not familiar with SQL, the syntax reminds a lot of English language that you write in a bit weird way and describe what you want to do with your data. Next, let's check out how to get this exactly same result by using KQL. Using KQL, we would say person and then pipe project, name and age. And with KQL, we first specify the table we want to query and then we add these operators with pipes. In this example, we just need the project operator that corresponds somewhat with the select statement in SQL. And you can use it to select the columns you want to have in your output. Then lastly, we have PySpark. Since it is Python, we use this object notation with this language. So we say person.select, that is our function here, and then we specify the columns we want for our output. Also, in order us to see our data, we have to wrap it to a display function that is very similar to a print function, and it will display our data with this nice table format. Next, let's have another example. In this example, we are using the same table / data frame, and again, let's start with SQL query. With this query, we would be able to get the number of rows from our table to a new table and with just one column called count, and one row that shows the number of rows. We are also renaming the count star function as count to make it look better in our output. With KQL, we have already an operator called count that shows the same result very easily. With PySpark, things get a bit more complex and we have to use aggregate function for our person data and then rename the result column from that function as count instead of count1. Then again, we wrap this to a display function to get that nice table format output. Also, I know that with PySpark there is easier ways to show the number of rows in a data frame by just using built-in count function, but now we want to have that as table and not as text output. Let's continue to talk about filtering data with these languages. With SQL, we can filter the data by using where statement, and for it we can, for example, say that we want only the rows where name equals Aleksi. This will then produce an output where we have only one row with the columns name and age that we specified in the select statement. With KQL, we can achieve this by using the where operator that works in a very similar way to SQL and then project the columns that we want to our output. In PySpark, we can use the filter function to filter name column in the person data frame and then selecting the columns that we want to the output. Also with PySpark, there are multiple different ways how this same result can be achieved, and now I'm just showing one of those here. In the next example, we are going to cover ordering our output rows with these languages. With SQL, we can add order by statement and say that we want our output to be ordered based on age. And I want the order to be ascending. With KQL, we have order by operator, and with that language we can order the data in very similar way. With PySpark, things work also in similar way, but now we have order by function for which we give the column we want to use as an argument, and then set ascending to be true. In the last example in this theory section, I want to talk about combining tables with joins. That is a very common operation when working with data. In this example, we have the same table we had previously, but now we have another table as well called person info. Now we would like to combine these tables using the name column. With SQL, we can specify a join command in our query and add our person info table there. Also in this query, I'm giving aliases to my table so I can refer to them in my query without writing their full names. After the join command, we have to specify the on, which we use to tell how these tables can be joined or combined. And there we are using name column from each table as the key for our join. Then in the select, I'm specifying that I want name and age column from the person table and info column from the person info table. And this will then produce the output we wanted. With KQL, we have very similar join operator that can be used to achieve the same result. With PySpark, we have the join function, and for it, we give the data frame we want to join as an argument, and then as a second argument, we provide the columns that are used to join the tables. And lastly, with the select function, we pick the columns we want to have in our output. This was the last example that I had in this theory section. Next, we will go to Fabric, where we are going to use all of these languages and highlight few more things about their differences. Before we open Fabric, I would like to know that I spent a ton of my free time creating these videos for you, and that's why I would like to hit that like button and subscribe to the channel for more DP-700 and Fabric content. This doesn't cost you anything, and I would highly appreciate that. Also, if you'd like to support the channel with a cup of coffee, you can do so by clicking the Buy Me a Coffee link that can be found in the description. But now, let's go to Fabric. Now I have my DP-700 workspace open here, and to this workspace I'm going to create a new item, and that item is going to be a warehouse, and let's find the warehouse from this list, and there it is. And then next we have to name our warehouse, and I'm going to name it VHDP700, and then let's hit create, and this will create this warehouse for us. And also remember that if you want to follow along with me, all the materials that I will be using in this tutorial can be found by clicking the link in the description. And since in this episode we are going to focus on programming languages, I'm not going to focus on these data stores that much, and we will come back to these in a later episode. But first we need to set up this warehouse so that we have some data here that we can query using SQL. And for that, we can create a new query, and here I have this setup script that I will run that will create a database schema here and then create a few tables that we can use to query with SQL and demonstrate some SQL queries in this episode. And now let's run this setup script here. And now this setup script is done, and we should have a new schema there, and there we have that new schema, and under that schema we should have some tables that we are going to query soon. And there we have employees, departments, projects, and assignments. And then let's create a new query and start to query those tables. Let's start with these very basic queries, and here I have 4 queries, and all of these queries will query the entire table that we have here. And SQL, we can use this star to indicate that we want to query all the columns that we have in that table. And now we can run this, and let's see how does the output look. And now they are done. And here we can see the employee table where we have the employee ID, name, department ID, hire date, and salary. And then in the result 2, we have the departments. And in the departments, we have the department ID, department name, manager, and location. Then we have the assignments table, and in that we have assignment ID, employee ID, project ID, assigned date, and role. And then in the 4th result, we have the projects table where we have project ID, project name, department, budget, and start date. Next, I would like to query the employees table and select the rows where salary exceeds $75,000 per year. And then I'm also using this concat function to add this $sign before my salary and making this new column called salary string. And let's see how does this look when we query this using SQL. And here we can see that now we only queried the rows from the employees table where the salary exceeds that 75,000 and created that new column salary string. And with SQL we can use multiple functions in this select statement to create new columns with some type of logic. This concat is just one simple example of that. Next, I want to demonstrate how to combine 2 tables with joins. And here we are combining the employee table with departments table. And we are joining them by using the department ID that can be found from the both tables. And then we are just selecting the name column from the employees table and also the department ID from the employees table and then the department name from the departments table. And now let's run this query and let's see how does the data look. And this is a very solid example of combining 2 tables with joins. That is a very common operation when working with data. And here we can see the output. And here we have those names, departments, and then the department names. And these department names were not present in the employees tables, and that's why we have to get them from the departments table if we want to show them in the same data set. And next I want to demonstrate this one cool feature in SQL that we can actually nest these queries, so that I will have the query that we had just there as a subquery for this upper level query that will basically use this result that we just created there to query that even more. So this way we can combine these queries together and build queries on top of queries to get just one result. And in this upper level query, when I'm querying this table that we had there as a result, I'm just counting the number of employees per department by using this group by statement. So I want to group by my data using the department name and then count the number of rows in each department to get the number of employees in that department. And now let's run this query and let's see how does the data look. And there we have, here we have the department name, and there we have the number of employees in that department. Also, it is good to keep in mind that SQL is not only a query language, and we can also manipulate the database objects like views and tables, and also grant permissions, etc. It's quite versatile language to work with databases. And for example, in my setup script, I already used these data manipulation features of SQL to create tables and insert data into tables. But these are the topics that we are not going to dive into this video. Also, if you're not familiar with SQL that much, you can start to query these tables that I have created here by using that setup script and set up this in your own warehouse. And you can, for example, try to combine these different tables with each other and come up with queries to train your SQL skills. Next, let's create an event house to this workspace so we can try out our KQL skills there. And let's find the event house. And now let's create this event house, and then we want to name our event house, and then let's hit create, and this will create the event house for us. And then we want to add some data to that event house. And here we just have some get started things. I will click this through so we get rid of this. And now we have that KQL database already created to this event house. And like with warehouse, we are not going to dive deep into what is an event house, and we will do that in a later episode. Now we will just focus on KQL and how that differs from SQL and PySpark to highlight those syntax differences here in Fabric. But yeah, now I would like to add data to this KQL database that I have here. And we can add data to this KQL database by using this get data feature and selecting local file. And I have those same datasets that we had in the warehouse as CSV files that I'm going to upload to this KQL database. And all of those CSV files can be found by clicking the link in the description. But now I want to add a new table to this event house and call that employees, and then I want to drag and drop that employee CSV file here. And there is the CSV file, and now it is uploading it, and then we can click next, and now we can see that our data looks a bit funky right now, and we have to click this first row as a column header so that now it looks correct. And this is the same data that we had in our warehouse. And now we can click finish, and then this will create that data to the KQL database. And now it is done, and we have that employees table here. And now let's repeat this same process to every file that we have here. And I'm not going to show this, and you can do that on your own. So we are going to upload 4 files here. And now I'm uploading the last project CSV file here, and same thing, first row as column header, and then we click finish. And then we should have all the data in our KQL database. And there we have those 4 tables, exactly the same tables we had in our warehouse. And now we would like to query these tables. And we can just click these 3 dots here and this query table. And we can, for example, show any 100 rows from the assignments table. And this will create this KQL query that will show the first 100 rows. And of course, we don't have 100 rows in our assignments table. So that's why it shows all the rows that is in that table. And this is also the take operator here that can be used to select the X number of rows. For example, we can just say take 1 and we will only see 1 row here. But yeah, let's clear this here and let's start to query our KQL table. And with KQL, we can just say the table name, for example, assignments, and query it that way. And this will actually query that table, and we don't need to specify any operators. We can just say the table name and then run, and that will query the table. And here we have the queries for these other tables, and we can run this one by one to see that we have the same data we had in those warehouse tables. So let's do the same thing we did with the SQL, and I want to select the persons from this employees table whose salary is 75,000 or more. And let's add a KQL query that would do that. And here we have that. So we're saying the employees, and then we have these operators. So we use this where operator and then salary greater or equal than 75,000, and then we want to project only the columns that we want. And also here I'm using this cat function that basically is the same function that we had in SQL as the concat function. And this is able to combine two strings together. For example, we're combining that $sign with that salary to get the same result. And now we can query this and see how does it look. And here we have basically the same result we had with that SQL statement, but by just using KQL and the KQL language here. Then the next thing that we did was to join those tables together, and here we have the corresponding KQL syntax. So we are starting from the employees table, and then we are doing a join, left outer join to be exact, to departments table using departments ID here. And then we are specifying the columns that we want to project from this data as a result. And now we can run this and see how does it look. And here we have exactly the same result that we had with our SQL statement previously. And remember, next with SQL, we did that subquery to be able to count the number of employees per department. With KQL, that looks a bit different, and we don't have to use that kind of a subquery structure. So basically now we're starting from employees, and then we have exactly the same join statement that we had previously, and then we are using this summarize operator here that will actually count the number of employees by using this count function, and then we are going to summarize by using the department name. So this corresponds to this kind of a group by statement that we could use in SQL. And now let's run this query and let's see how does it look. And here we can see the same result that we got with SQL. Also the same thing here, that if you want to start practicing your KQL skills, you can use these tables that we uploaded here and use them to do different kinds of queries and try out these different kind of KQL operators to really understand them and to be able to answer to some questions in the DP-700 exam related to KQL syntax. Next, we want to create a lakehouse to this workspace, and we can select the lakehouse here, and then we want to name our lakehouse, and then we are actually going to use lakehouse with schemas, because I predict that soon or later we are only going to have lakehouses with schemas, and that's going to be the standard in Fabric. But like with those other two data stores, we are not going to focus on lakehouse as a data store in this episode, and we will come back to it in a later episode. But yeah, let's enable those schemas and let's hit create, and this will create that lakehouse for us. And now to this lakehouse, I want to first create a new schema, and we can create that schema DP-700 episode 4, and then we want to also create a new folder to this lakehouse with the same name under this file section and call that DP-700 episode 4. And to this folder I'm going to upload those exactly the same CSV files that we used with our KQL database. And we can use that upload files, and with this browse functionality I'm going to find those files and add them here. And now I have added those files here, and then we can click upload, and now they have been uploaded, and we can close this, and they are now in this folder here. And now we can actually turn them into delta tables so that we can more easily use them. And we can select this load to table and new table, and then we select our schema and we use these default settings here, and then we click OK, and then we have to wait that finishes. And now I'm going to do the same operation for every CSV file here. So we will come back to this in just a moment. And now we have loaded in that projects table as well, and now we should have 4 tables in this schema. And there we have these delta tables that we create based on these CSV files here. Next, I'm going to create a notebook, and we're going to use that notebook to query those tables and use PySpark to transform the data in a similar fashion we did with SQL and KQL previously. And here we have a blank notebook. And again, we are not going to dive too deep into what is a notebook in this episode, and we will come back to notebooks in later episodes. But now we just want to demonstrate the programming languages. And here I have already attached that lakehouse to this notebook, since it is attached by default since we created this notebook from the lakehouse UI. And I want to note one thing about notebooks before going forward, that we can use different languages with these notebooks. Like I described previously, we have different languages for interacting with Spark. In this case, I want to use the PySpark API, but we have also the Spark SQL. So basically, we would be able to use SQL to query these delta tables here. Now I add these statements here that utilize Spark SQL to query these tables here into data frames. And then we are going to use these data frames in our PySpark code and do those same kind of transformations for those data frames. But yeah, let's run these and let's run them into these data frames here so that we can start our work here. And now our code has executed, so we have now these 4 data frames where we have basically all the data that we had in those delta tables. And then we can add some code and display these data frames that we have here. And for that, we can use the display function that I showed you earlier. And by running this, we would be able to display all of those data frames in this very nice table format, like we did in those theory section slides. Here we can see exactly the same data that we have been seeing already previously by using that display function here. And next, I would like to get those employees with that salary 75,000 or above. And for that, we can add a new cell, and to this cell, we add this PySpark code. And here I'm importing these PySpark SQL functions as F, so we can refer some of the functions that we have in this library. Like for example, the concat function and the lit function and the call function. But yeah, with this code, you would be able to get those employees whose salary is equal or greater to that 75,000. And with this PySpark syntax, we're first referring to the data frame, and then we are using this object notation to do some things to that data frame. For example, we are first filtering that data frame, and then we are selecting the columns that we want from that data frame that will then actually display them using this display function here. Also, we are using a concat function to add that $sign before that salary and naming that salary string. But yeah, let's run this code and let's see how does the data look. The result should be the same result that we had with SQL and KQL previously, but by just using this PySpark code here and the PySpark syntax to query and read that data. And there we have that result, and the result looks exactly the same that we had previously, but now using a different language once again. And also I want to remind you that this is just one way of doing this with PySpark, and with PySpark we have some flexibility that we can do with our data, and we have some different options, but this is just one way of achieving this result. And here I want to demonstrate another way of getting that same result by using this select expression function, and now we don't have to import those PySpark functions, and we can just use this select expression and here do some things and use those pipes to combine those 2 columns together. And by running this, we should get exactly the same result that we had above, but using just a different way of doing that. And there we can see that these are exactly the same. Next, we want to do those joins to those employees and departments data frames, and this will go in this manner that first we start with our employees table, and then we are using the join function, and then we are going to give the departments data frame as a first argument, and then we are going to combine them by using department ID from both tables, and then we are specifying that this is a left join. And then we are selecting just those columns that we want from each data frame by using the select statement. And now let's run this and let's see how does the data look. The result should be exactly the same that we had with KQL and SQL previously. And here we can see the same result. And again, I want to demonstrate the different way of doing that same thing with these PySpark functions and using these aliases for those tables. And with this code here, we get exactly the same result we got here, but now using a different syntax. And now we are actually using that select statement that we already used previously. And then we're using that column function from this PySpark functions library here. But the result is same by just using a slightly different syntax this time. And as a last exercise, we wanted to count the number of employees per department. And that we can achieve with PySpark by first starting with the employees table and then having that join statement. And then we're having that group by statement in very similar fashion to SQL. And then we're specifying that we want to group by department name. And then after that, we are going to have that count function. And then we are also going to rename the count function output to number of employees so that we don't have this column called count and we have the number of employees there. And now let's run this and let's see how does it look when we run this. And here we can see the result from this query. And I was just wondering, did I do something wrong? But actually we didn't see the last row here. So it is basically 2 employees per department. And I was a little bit confused here that did I make a mistake, but I didn't. And with PySpark, we have multiple ways of doing this same thing. And here's another way of using those aliases and those PySpark functions, and this will achieve actually the same result we had there by just using this different syntax, and here we have the same result we had there. And again, the same thing, if you want to practice your PySpark skills, try to do some different things with these tables that we have here to practice some of the syntax here so that you're prepared if they ask something about PySpark syntax in the DP-700 exam. Next, let's have some questions related to today's topic. And let's start with this question 1. Which T-SQL query will produce the following output? And here we can see that we have this animals table, and in that animals tables we have the animal column, then we have the group column, and then we have the habitat column. And in the output we only have the group column, and then we have the number of animals in that group. So we would like to get that by using SQL. So, are we able to achieve this result by using the query A, or query B, or query C, or query D? Now think about this question for a moment and pause the video. And I will reveal the answer in 3, 2, 1. And we can see that the answer C is correct this time. And here I'm highlighting what are the issues in those other queries. In the query A, we are using that group using that is not a proper SQL syntax. So it is group by and not group using. And in the query B, the problem is that we are only selecting the count as number of animals, but we are not selecting the group column at all. And in the D query, we are using this equal sign instead of S. That is the proper SQL syntax way of saying that we want the count as number of animals and not count equals number of animals. Next, let's have another question, and this time about KQL. Which KQL query will produce the following output? And now we have exactly the same input table we had there, and now in our output we have only the group column and only the habitat column, and we have dropped out the chameleon row from that table. And now you would need to know which of the KQL queries would be able to produce this output. Is it the query A, or query B, or query C, or query D? Now think about the answer to this question for a moment, and I will reveal the answer to you in 3, 2, 1. And the correct answer to this question is the query A. And again, I'm highlighting what are the issues with these different queries. In the query B, the problem is that we are specifying the columns that we want, but we are missing the project operator that is used to show the columns. And in the query C, the problem is that we are using select, and instead of select, we should use the project operator, since that is the correct KQL syntax. And in the query D, we are using this take operator instead of where operator, so that should be the correct operator there. And now let's have one more question related to PySpark. Which PySpark code will produce the following output? And here again we have that animals table, and in the output we have only the chameleon row now. And now you need to know which PySpark code will be able to produce this output. Is it the code A, or code B, or code C, or code D? Now think about the answer to this question for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer to this is the code D. And again, I'm highlighting what are the issues with these different codes. If we start from the code A, we can see that we are using this take function that is obviously incorrect since we would need to use filter function. In the code B, the problem is that we are saying animal is chameleon and that is operator is incorrect there and we should use a double equal sign there. And in the code C, the order is wrong because we will start from the data frame that we are going to filter and then saying dot filter and using that filter function to that data frame and not other way around. And that is all that I wanted to cover today. I hope that you learned something new about these programming languages and now are more prepared to take that DP-700 exam. And speaking of that exam, if you want to continue learning more towards getting that badge, check out the next video in this series. But now I thank you for watching and see you in that video.